Digital experiments is a way to use HTML and Java to make interactive tools for the students. So instead of having a static learning environment and learning tools, we can somehow use AI to build these tools more dynamically and in a way that is custom tailored to the individual lessons and the individual level of the student as well.
Yeah, digital experiments are a way to visualize different concepts in teaching, and they aid the static tools we have available like books and lectures, and provide a sort of dynamic way to visualize processes.
So I think here at DTU Physics, me and my colleagues have used these sort of programs to illustrate and also to provide experimental kind of environments where students could play. We have used these sort of techniques for several decades. So I think so that's nothing new for us. But I think this particular way of doing it lowers the barrier enormously for employing these in teaching, so that suddenly it's not like several years to create a really good instrument. It's a few minutes.
So I think for me there's kind of like two answers or two parts to that question. One is, as a student, I could see that the way I really benefited from learning was to do something hands-on in the classes. The second part is that we had a discussion about how to use AI for teaching. What does the future look like in terms of teaching material for students now, when everything can be done with large language models? And someday it kind of clicked that, maybe we can use the language models as a tool to build these interactive models and kind of like playgrounds for the students.
I have always wanted to visualize some of the difficult concepts we learn in physics through either an animation or a small video, but often that has been would be a huge time investment to create physically accurate animations. But with the advent of AI, it has been possible to relatively easy make these digital experiments, which even far surpass the animations I had thought about, and now allow the students to also interact directly with some of the parameters governing some physical laws.
So digital experiments is a way of reversing the order that we traditionally have for teaching, because you can lead with the unknown, right? The unknown is per definition the purpose of teaching, like to learn what we don't know already. But here we have a much more natural discovery-based workflow, and which does not compromise on the depth of the knowledge and the theory, because it comes afterwards. But we start with experiments.
Early on, as we are kids and we progress throughout school, a lot of the really effective teaching is done through playing and having kids kind of like be curious about discovering the rules of some game or using those rules to win the game. And now we have the opportunity to use AI to kind of like build games and build competition, for instance, into these small digital apps, which I think can be an extremely powerful tool for kind of curiosity-driven learning from the students.
Also let's say the time dependence of it, because books are static, pictures are static. It does not always give you a good, clear understanding of how time is involved in these physical processes. But with these digital experiments, it's suddenly very easy to make an animation that you can vary, and depending on what process you are looking at. And suddenly you get a much better understanding and a much easier tool to teach students about the dynamic part of the physics.
That's a great question, which we thought a lot about, because the first thing you do is to show one of these experiments to somebody, and at some point people would like to try themselves. So that's kind of a natural progression. We thought of sort of a schematic where the level 0 is demonstration, where maybe the teacher is demonstrating something on a PowerPoint or whatever on the screen, and the students experiment and learn something by playing with the system and trying to play with it themselves. Maybe they have to validate it. That could be another more high-level exercise. They have to prove to each other and to me maybe that the model is correct, and finally maybe create or improve so that they can learn that how do I make something that is more sophisticated, has a different kind of ranges of applicability and things like that. So it's like when we teach with these digital experiments, we have to think about where we are on this ladder and remember that we don't have to stay here, but we can go all the way up here where the students are creating their own experiments, own systems that they work with. Yeah, so far it's early times. We have definitely used it for demonstrations, like you got the 0th level, but for experimentation, it really works well. The applications start up immediately, and they can get access to the functionality within seconds. But we've also seen with some more advanced students that they actually embrace the possibility of expanding and building on these systems themselves. So we think that there's a very natural flow from the basic levels to the more advanced levels.
So my goal for the students to use DEX is for them to be curious about what is going on in the simulation. So you can imagine a small experiment I'm showing them with parameters, simulating some real physical phenomena. The students then could have some kind of an assignment where they're supposed to figure out the best way to optimize some part of that process. And then naturally they're going to want to understand, okay, but what were the laws governing what we played around with before? And then in the end, they will have some kind of an intuitive and curiosity-driven understanding of the phenomena because they had the possibility to do this digital experiment.
So far, I have created DEX using large language models, specifically ChatGPT, and it has been extremely simple. I have simply, if I wanted to clarify some concept, I have simply asked ChatGPT to create a simulator that may show some physical phenomena, and the key thing is that the simulator is stored in an HTML file, and then it is openable on basically any browser and also within D2 Learn that we use. So it's very simple to access and it runs very fast.
Models like ChatGPT or Gemini. So specifically, because these models are incredibly good at HTML and Java, that's what we use to kind of like as a framework for the DEX. And there's really no limit to what we can ask these models to do. They are incredibly flexible. So we can do simulation of physical phenomena, we can do fabrication-related games, and really the only limitation to what we can do with these models is our own imagination and creativity.
The moment you want to do something that is more correct or complicated or has multiple functions, which you sometimes need, or specific types of problems, it can be pretty difficult. But there's a lot of techniques that you can use in order to overcome the limitations of the large language model or whatever software you're using. So there's a lot of tricks that you can sort of kind of reboot whenever the program or the digital experiment code is somehow going off the rails, and then get back on track.
Specifically for myself, I find myself reaching for these DEX to understand phenomena. Like it turns out things are so easy to simulate with these powerful language models that even some of my own papers where I have like static images, I told the AI to then generate a slider for this, make this simulation dynamic, and that has been instructive for me, even though I was supposed to be the one who was the authority on this topic. So I find it personally incredibly powerful to have this on-demand visualization and on-demand software that you really get with these DEX.
I have exactly the same experience, that I start to understand things better that I kind of thought I already understand, or I develop intuition where I maybe didn't have a strong one. And I think that is something that I also see in the students that have experimented with so far, that they develop intuition at a different pace and also understand things in a different way than if you just stare at the equations. I think we still need the math and we still need the students to bury themselves in the theory, but it comes in much more natural when you have you are starting with an experiment. And I think for me, I'm also in the same way. Sort of sometimes if there's a new topic that I'm struggling to understand, then I try to make some visualizations and trying to get the basic principles, under my skin, and that really helps when I dive into the theory.
I think we have a responsibility as teachers to really figure out what are the pros and cons of these digital experiments. I don't think necessarily just because everything can be interactive and digital and sliders and visual, that it's necessarily the best for every topic for the students in terms of like learning objectives. But we really don't know yet. So starting in the spring, we are systematically implementing these tools in a course, and we will kind of work with the students to figure out what is good, what is bad, how can we improve, and what are the limits of these digital experiments.
Well, I feel that for maybe the first time since these very capable large language models have come out, this is maybe the first application of it in teaching that I think actually supports the learning of the students. And I'm still exploring what DEX can do in that regard. And the first thing I will try out is to get some feedback from the students.
Obviously, we are going to try it out and measure the effect. We are pretty humble towards the challenge of making teaching much better in a single stroke. We don't think it necessarily works like that, but we think there's a possibility that this could be groundbreaking in terms of at least the way we teach, and whether it's useful for others, we are not the right ones to decide. But I think that we're going to give it a fair shot in terms of really trying to push this, see how far we can get, how advanced things we can create, and how that affects the students' understanding. And until we kind of know that, we don't really know how useful this is going to be. But I think honestly, personally, I think this has a potential to be a very important asset in our struggle to make the best teaching in the world.